All right, we are going to look at the momentum lab write-up today. And so for the momentum lab write-up, there's basically three kind of categories of collisions we had. We had the inelastic-elastic collision. We weren't sure which one it was. We had the recoil collision, and we had the perfectly inelastic collision. I'm going to show you what we're going to do with the data we collected from those three types of collisions. So in all of them, we are hoping that there was no net external forces on the system. There was forces between the objects that were colliding, the carts, but there was nothing else outside, like friction or you pushing on it, something like that during that collision. And so if that is true, momentum is conserved. So we want to see, was that true? How true was that for us? Okay. So we want to test to see if the momentum before was equal to the momentum afterwards. So for our perfectly inelastic situation and our elastic-inelastic situation, what we're going to do is we're going to do percent difference. We're going to look at how much momentum did we start with. So we'll do m1v1 plus m2v2 is equal to the momentum afterwards. And we're going to compare these two values. We're going to see if this equal sign is true. Now remember, when you're finding these individual momentums of the two objects, remember to flip, say, the red car's velocity so that they both have a common coordinate system. Okay, so you're going to find this momentum, you're going to find that momentum, and you're going to take the difference, find the absolute value, divide it by the average, and multiply by 100. Okay, that will give you your percent difference. For perfectly inelastic, you should be getting very good percent differences. This one is a good experiment for us, so we should be something like 1%, around there. For the for the elastic, inelastic, this one's not going to give you as good a results, but you should be less than 10%. And that's kind of a good point to think about when you get to discussing these results. Why was that in our experiment that we were getting numbers in those kind of ranges? Okay. For the recoil, it's a little different. We can't do percent difference because they start at rest, so there's none before. But what we do know is we know that these two have to be opposite and equal, so when they add together, I get 0. So what we'll do is we're going to go ahead and compare the magnitudes of the two carts after they push off one another. So you're going to go ahead and find their magnitudes. That just means don't worry about the directions. Take the difference of the magnitudes divided by the average of the magnitudes times 100 to get percent difference there. Okay, so this is all about us testing to see if momentum was conserved and how well or how poorly was it conserved and what might have influenced that. And for recoil, you should get another good number like 1-2% percent difference, I'm sorry. Now, the inelastic-elastic collision, let's think about what's going on there. And so what we got to do is we got to say, all right, if it's elastic, the change in kinetic energy is 0. If it's inelastic, the change in kinetic energy is negative. So what we're going to do is we're going to go ahead and find the percent energy loss. This is essentially the percent air if I'm expecting this to happen, that it should equal 0. So we're going to take the final kinetic energy minus the initial divided by the initial times 100 will give us how much energy was lost. We should end up with a negative number. If it's inelastic, we should end up with 0% difference. If it's elastic, you end up with a positive number that's suggesting energy was gained in the situation, which probably not the case for us, okay? Or is not the case, I probably should say. So here we go. We have this kinetic energy is the initial, so you add up the kinetic energies of both before. The kinetic energy after is, as you expect, the kinetic energies after added together. And again, at the end, make sure you discuss your results. Tell me what these things mean. What does it mean if I have a 1% error? What does it mean if I have a 10% error and percent difference? Sorry. What does it mean if this comes out to be a negative 0.1% energy loss, or what does it mean if it's a 10% energy loss? What does that mean for this scenario, and what could be affecting those answers? Good.